Okay, so let's see what we are going to see in data science with Julia for today, right? Uh, right. So today we are going to see just a second. Let me just do some settings changes. Okay. We are going to see more about functions, like what we can do with functions and some more tips and tricks and all those stuff, right? So whatever you have learned here, you can use that and use write almost any conceivable program. But there are some tips and tricks that makes a language better and all those things. Uh, Possibly that might be the reason why you choose one language over another and all those stuff. So for scientific computing and for scientific world, Julia comes from scientific world. So it's very good. If you yeah, and yeah, another tip is like if you're using MATLAB, I think you can just move to Julia. So that's another tip. That might, yeah, bother some MATLAB people and all those stuff. But that's the thing. Like for MATLAB, I think you need hefty money to start and all those stuff. For Julia, I don't think you need it. So what's happening over here? Oh, okay. I'm opening consoles over here. Okay, sorry. Okay, yeah. So I just put a file and I'll just rename it like functions tricks. Okay, so you have written function with keyword function and all those stuff. So what about a function like y of x is equal to 2x plus 3? How natural it is, right? So let's put like y of 7, right? So that's how it is. That's how easy it's to create a function. Like in just one line, you can just create and all those stuff. It's kind of very mathematical in nature, like in Julia. So that's the thing. And let me just move this. Or am I not log? But yeah, let me just move this over here or somewhere over here so that I can access it easily. Okay, yeah, fine. So as simple as that. So now, yeah, let's see what's next. Yeah. So you have a vector. 1, 2, 3, 4 is a vector. So let's say like you want to make this function act on a vector. Okay. So all you just need to do is this dot, right? So what is y of 1? 2 plus 3 is 5. Similarly, what is y of 2? Y of 3 and y of 4. So now imagine like how easy it has become. Like no need to write all this for loops and all those things. Like similarly, like it's not like just like this one line function you can do like this on a vector. I can also write a function like this, right? And I can make it act on a vector, just like this one. Just put dot. That's it. That's it. So, right? I can even test like y1 of 4, right? 11, right? So as good as it. So as it could get possibly, right? So that's how it is. Yeah, now look, I'm just doing it for range. So possibly think of doing sine and cosine and all those stuff. Like we can do it for one full range. Okay, so that's the thing. And yeah, so this is a range. Okay, so I think I call these as collectibles or iteratables. You can iterate, right? Like all those things. So that's the thing. So yeah, and it just works. And let me just do it for a tuple, right? So tuple, you just do it like this, and you just put 1, 2, 3, and 4, right? Oops, I need to put this dot operator over here. It means for each, right? So I think we had used this somewhere. I'm not sure. I'm really not sure. So I think in arrays we have used, I think, right? So like there is a array. Uh, 1, 2, 3, or a vector. Okay, 3, 4. Okay. Actually, vector multiplied with scalar will give a vector, right? So this will be an element-wise operator. Okay, and actually you can even multiply a vector with a scalar. So that's one property of vector, right? So Ra is a vector in Julia. Okay, so then like let me put a tuple. Okay, tuple 1, 2, 3, 4. Right now, let me try to multiply this with 7. Tuple star dot 7. Right? You get another tuple. So if I put tuple, yeah, this gives an error. So this means element wise, like whether you mean tuple, range, or whatever it is. So let me just do another thing. 1 to 4. This is a range, right? I can do this multiplied by 7 over here. Oh, 1 to 28. This also gives a range. Okay, that's very good. Right? So, okay. So I'm getting excited over here. So let me try something. Okay. 1 in steps of 2 till 10. This I'll multiply it by 7. Wow. Okay. Now, without this dot operator, let me just try to do it. Okay, fine. It still works. Okay. So, but for all connections, okay, maybe this could be kind of thought of the dot star or dot whatever it is. Can be thought of a universal operator where it will take each and every element and apply that function or whatever it is operation on each and everything. So you can remember it's something like that, right? So that's the thing. So yeah, this I was just curious. Okay, maybe you won't be finding these in my blog, right? My blog might only say like what works. It might not say what doesn't work. Okay, so yeah, so there is a thing called map. Okay, so let me just show you. So you know why, uh, you know what y is. Why we have defined 2x plus 3. So you can also do something like this one. Like if you want to be more explicit or something like that. I would really prefer this one. I don't know why, but I would prefer this one. Maybe it's concise or something like that. So this will take each and every element, map it to this one. So that's the thing. I think we can map everything like that. So I think we can make this as a tuple and map, right? And I don't know whether we'll get as vector or tuple when we map a tuple, right? Okay. Okay. So map is something like, okay, yeah, fine. Let me think about it. Okay, yeah, fine. Right. So then what is y dot a tuple means? Does it give a vector or tuple? Yeah, it gives a tuple. Yeah, it's intelligent. Julia is intelligent, right? Okay, fine. Right. So when I say Julia is dumb, I don't mean to offend any girl named Julia or whatever it is. Right. So just a disclaimer. Right. Okay, right. So now I said Julia is intelligent, right? So yeah, that also doesn't mean like I praise a girl called Julia, right? Yeah. So where was I? Okay, yeah, this map one. Okay, I just want to see whether map works on range. Okay, this might be more about functions, but I'm just curious, like what this map does. 1 to 10, right? Okay, if that does something like this, what does y dot 1 to 10 does? Okay, right. So, okay, it gets mapped to a vector and all the stuff. Not something like, okay, what is 2x plus 3 of 1, where x is equal to 1. So that will be like 5, right? It's not like 5 2 and 2x plus 3 of, that is like if you put 10 to 2x plus 3, it will be like uh, 2023. No, it's not doing like that, right? So that's the thing. Right. So yeah. So this is what map and all those stuff. Yeah, this okay, and there is a thing called anonymous function. Like a function need not have name. Look, this function has a name called y. This function has a name called y1. This is a function name, right? We use it to identify the function to call that function and all those stuff. That's what names are used for, right? Even your name is being used for whether pet name or whatever, like your name, what your dad, mom kept, or something like that. Your official name. Okay. So that's been used to call you. So that's what function names or even variable names are being used. But you can have functions without any names. This one has no name, right? So all it just does is it just takes x and puts into 2x plus 3. And this you just pass it to map, right? So that's how it is. And yeah, another thing, you can rearrange cells in Julia, right? So yeah, sorry, in Jupyter Notebook. And this is a Jupyter Notebook thing, not a Julia thing. I use Jupyter Notebook to teach Julia because Notebook and Jupyter Labs are being extensively used by data scientists all around the world, right? So that's the thing, right? So yeah, that's how it is, right? So this is a function, but it has got no name. All it says is like map this value to this one. So yeah, that's how it works. So yeah, and that's it. And what if, okay, before and all, like in some and all, some or addition functions, we had two arguments, right? But what if I want to do a lot of arguments, right? So let me just take this and put it. So before that, let me just tweak it. Okay, so I'll put it over here. So now I'll just do, okay, like println numbers. Okay, and then println type of numbers, right? Okay, so that's what I did. Okay, now let me do, okay, like var some, okay, yeah. Um, yeah, so now let me take this one, right, and do something like 1, 2, 3, 4. So okay, so numbers have been printed and you're getting its type as tuple. So that's how it is. So you can pass whatever arguments, how many ever arguments you want, so you'll get it as tuple. So whatever operations you can do with tuple, you can do. So what I'm just doing is like, okay, I just want to put some a function called var sum, where it totals all the numbers that's been passed to it, right? So I'm just doing it. Let me just put it as 1. Okay, so that like I don't want to clash with this one and confuse and all those stuff. Okay, so actually I should have named it as variable arguments, right? So that's how I should have named it. Okay, variable arguments, right? So this I'll just put it as where are sums. Okay, so okay, so now I can just use this var, okay, var on sum. Okay, so now 1, 2, 3, 4. Yeah, fine. So it works. So what happens is it just, okay, first we initialize total as 0. Now this numbers is what to say, tuple. It contains like 1, 2, 3, 4 in it, right? So this 1, 2, 3, 4, each and everything goes to this number, right? So and over here like total plus is equal to numbers take place, and finally, yeah, we just return the total. The last statement in any function in Julia gets returned. No need to give explicitly return. Okay, so that's how it is. So yeah, that's how variable arguments. Yeah, I've put another example, but I just don't want to confuse, right? So okay, yeah, maybe we can do it. Like, look. uh, so we are giving something like base is 0 and numbers is something like this. Okay, so like what you can have is like you can have some mandatory arguments which you need. Okay, and then followed by optional arguments which might or might not be used or something like that. And so here I've just put base. So what it will do is like okay, it'll just okay. You can imagine something like this. It'll compute the total of these all these things, add it to the base, and puts out. So it'll these will be 10, and it'll be added to 5, and so it'll be 15 and something like that. Okay, let me give it a 7 or something like that, right? So that's how it is, right? Yeah. So, um, yeah. So that's how it is. Like, if you want, you can. I'll just rename it as something else. Base one. Okay. So, yeah. I think you would have got it. So, like, Brentland base. So whatever you give first goes goes to this base, and whatever you give after this one goes to this numbers. Okay, so I should put a better name for this, but yeah. Anyway. So 9, 7, 2, 1. So the 9 will go to the base and 7 to 1 will go to numbers. So that's how it is. And how you say this is a will take variable arguments thing. The numbers is being followed by three dots or anything that's been followed by three dots, and this should appear only at the last. Okay, this should appear only at the last in the function. So any variable followed with three dots that appears last in the function arguments will take variable number of arguments into it, and it will be a tuple. It will be represented as tuple inside the function, and you can do whatever you want with it. So that's how it is, right? So right, okay. Okay, so there's still more, right? So, uh, actually, there's a thing called sum. Okay, so sum of 1 to 10. So the sum just sums up everything. Okay, so you can just think like it's a bare arc sum on steroids or something like that, right? And there's a thing called square root. Square root is QRT of. Is there a variable called answer in JupyterLab? Yeah, okay. So I'll just put it down. Okay, like this. I'll just put. Now I'll just put like QRT of answer. Right. I don't know. I was working with Jupyter Lab before. I think like I typed an answer and I got it. So yeah. So this one finds a square root. So there are ways to pipe functions to this one. So what you can just do is you can just simply put like this one. So 1 to 10 goes to sum, and that goes to square root. So it all depends. Like rather than writing like SQRT of sum of 1 to 10, that would be a bit confusing, right? So maybe yeah, this one makes more easier. And I think you can also write something like yeah, this one SQRT C dot sum and then 1 to 10, right? Okay, so 1 to 10 will go to sum and then SQRT, right? But I feel this one is really good, right? But you can't change over here. This C dot and all don't think like it's uh what they say, associative or commutative, like associative law, right? Okay, right. This is associative, so I think commutative. Commutative property. Okay. Yeah, x star y is equal to y star x. Okay, that's commutative property, right? So yeah, that thing don't think that will apply here. Don't think that will apply over here. So don't think you can put this. You can interchange this sum and square root, and you will get it. So because yeah, some people who are starting, yeah, they will get all these doubts. That's the thing. So don't think like okay, that'll somehow figure out and do no. That's not so, right? So yeah. So yeah, that's the thing. So I'll also link my blog in this video. Anyway, thanks for watching. I hope you're learning Julia well. We'll soon touch into data science. Actually, there is a thing like okay, like blog. I've just put like if you want to see driving a car with genetic algorithm. Possibly, yeah, I'll explain this. Right. So yeah, and this and I need to explain something with that, like guessing a number with genetic algorithm. So if I explain these two with each other, so you might understand. So, but yeah, before that, we'll do some plotting, basic plotting, and something like that. Uh, okay, yeah, that's it. Or shall I do passing function as argument? So I'm not sure. So, but yeah, let me see. What is good, or what I'm prepared to take lecture up on. Let me see. So that's the thing. Anyway, thanks for watching.